All right, guys, we're gonna start real quick. Okay, let's start our class. Good morning, everyone. Welcome back. I really appreciate you guys' effort, struggles, on assignment. I know that's a lot, so I will talk about the assignment and also discuss with you guys the next step very quickly, like so. But just like before that, I just want to have a prologue for today's class first. So like we already talked about the heat last time. So this time, or if you already watched the video, it's still about heat. So we are introducing a new type of vulnerabilities, which is double free. Actually, I also mentioned about heap overflow in this week, but I would say this week is mostly about double free. And I will give you more details or walk you through double free vulnerabilities later on. But before that, let's talk about logistics, which is assignment. So I do receive many messages from you guys in terms of like, is it possible to extend the deadline or specific, debugging questions in terms of this assignment? And as I mentioned in Discord, I'm sorry that I cannot really handle your debugging questions online through Discord. And then I think the best way is to join the office hour. Go to my office hour, the TA's office hour, share your screens there because that's the most straightforward way. We can directly access your computer using the control format and help you debug. So yeah, so if you have any debugging questions, I think that is the best way to go. And also besides that, deadline, I know that you are still struggling with that. So here's my plan. So first of all, I am going to extend today's deadline. That will be into right now I'm saying into April 1st. So you're probably gonna have 4 or 5 more days. However, that doesn't mean that this is the final extension. Okay. The reason why I'm doing this is because I want to use this time window to have a poll on Discord because I want to collect the information not only from you guys, not only from Tuesday session, but also from the Thursday session. In the sense that I want you guys to give me information such as A, do you think that you need more extension? Okay. And then B, do you think that it will be helpful if we have next week to be another Q&A session for this assignment? And I will talk about challenge 5 because I realized that there is a gap between challenge 4 and challenge 5. If you look at the number of solutions, right? So it sounds like there is a technical leap there, and I know that many of you are suffering. So I can have another Q&A session, mostly focused on challenge 5. And hopefully starting from there, it will give you more hints or give you more confidence for you to continue with these challenges. So again, I know that you've suffered a lot. I'm sorry about that, but the purpose is not to give you 0 score after struggling, right? So I do want to give you guys credits. So this is what I have in my mind right now in terms of how we can move forward for assignment 2. But if you do have other, you think, useful, suggestions, like logistics wise, feel free to let me know. I will also consider that. Okay. So yeah, so this is my current plan. So at least you will have 5 more days. Today's 27th, right? So 28th. Oh, okay. So that means that you have 4 more days until Saturday. Okay, which is April the 1st. And this is not April Fool's joke. So I mean, this is serious. Okay. Cool. Okay. Awesome. Does it sound good? Good. Good. Awesome. Yes.
We are not able to kind of move forward in current side. So it will be better if we get some things like how to start on it. Because
I see.
today it's not gonna help much because we're not able to.
Sure. Yeah, I can give you guys some hints in terms of challenge 5. And hopefully that will be good enough for you to use the rest of it. And also, again, just as I said, it's gonna be a poll. And if you tell me that, hey, actually, I don't want more time to work on that. I don't want to even think about this anymore. I'm so exhausted, but this is done for me. No, it's fair. I know how torturous it can be, right? So that's why I like to have a poll to really ask your decision or ask your suggestion, even though that you want to give up on this. Like you can just like make a cross there saying that I don't want any extension. I'm so done with it. That's fine. That's not a problem. Okay. I just want to know your opinion and then make a decision based on the count. Yes.
I think the need to be on challenge part is sending a raw attack using format because we did proper workflow for like 5-6 weeks. And then the assignment was given, so we had a lot of time to understand it from scratch. But with format, it's very difficult to understand everything once.
Step by step, right?
There's only one class left for it.
Yeah, I see. Yeah, thanks for the suggestion. I mean, I hope that in the future, in the next time when I teach this, I will give format string more labs. And then for this time, like talking about the solution, I will say maybe next week, a Q&A that we talk about challenge 5, which we will get involved with Rob, right? I hope that this will be good enough for you to do challenge 5 and beyond. Does it sound good? I mean, if you want like another lab, I can also do that, but I think maybe doing this strictly on challenge 5 might be more straightforward. And maybe something that, because I know that everyone has a different and has a customized challenge, right? So what I could potentially do is that either have one challenge, like challenge 2, right? Like one universal challenge. Everyone has the same one. But then later on, you need to repurpose that to your own challenge 5. Okay. Or we have a lab that has very similar stuff to challenge 5. And then, but still, I mean, either way, you need to repurpose because at the end of the day, you guys all have different challenge 5s. Does that make sense? Okay, good, cool. All right, yes.
Also, the final CGF would be take home or in class.
It will be take home. It will be like assignment.
Okay.
Yeah, and actually, I'm still deciding how we're gonna have this final CGF. I haven't decided yet, so I'm not gonna leak any information yet. But I'm very sure at least it won't be in class. It will be at least a take home. It's just like, what are those challenges? What are those challenges from? That will be a question that I haven't decided in my mind. Okay, more questions? No? Good, okay. So let's continue. Now, I hope that so far you can forget about, I mean, at least for now, you can forget about format string. Let's just move on to the heap to talk about the interesting, the cool stuff on heaps, okay, like those vulnerabilities. Okay, so I'm gonna have a quick poll first, very quick, like raise your hand if you already watched the videos. Okay, I just want to know how many of you. It's okay that you haven't watched it. Okay, good. So we have about half a student that already watched the videos. That's great. So in this video, in this week's videos, I should say, there are 3 videos there. It tackles 2 vulnerabilities. One is double frame and the other is heap overflow. Okay, so questions. Do you have any questions in terms of double frame? I'd like to walk you through, but I want to know if you think it's necessary for me to walk you through. Yes, okay.
Yeah.
Okay, yeah, do you have a specific question for double frame? Okay, good. Also, okay, so can you tell me your question first?
Yeah, so the question is like, why does the double free actually work? Like, and what would be the diagram after we attack?
Yes.
And like, why? Because the block 1 attaches itself to itself, and then we are freeing it. So which one of it is getting freed and which one is getting attached to the victim? That was not very clear.
I see. Okay, yeah. And what was your question also?
Only
Similar question?
Yeah,
Okay.
But since the double free point is pointing to itself, so why can't it point to something else and still work?
Okay, yeah. Good questions. Okay, so then I think maybe the best way is to walk through double free and that will answer those questions pretty clearly. So let me see where to start. Okay, let's start from here. So the overall idea for double free is that you have a chunk, right? And then you free that chunk for twice. And then in Tcash, whenever you free a chunk, that chunk will go to the Tcash, right? I mean, of course, there's some preliminary conditions here, but you right now, let's not worry about that to say, whenever this chunk is within the size, and actually there is their capacity limit for Tcash, but let's also not worry about that. Let's say that we have enough space for Tcash right now. So that means that if we have a chunk, say in the size of hex 20, by the time that it's free, it will go to Tcash, right? So the high level idea for double free is that you want to free the same chunk for twice, so that this chunk will occur in the Tcash's chain twice. And then why is that good? Because if you can make this chunk occur for twice, then the next time when you reallocate, when you ask to do malloc again, you will get this chunk, right? And then you can use this chunk to write whatever information. And this is similar to use after free in the sense that you have a chunk that is freed, means that it's in the Tcash chain, but you can also access it. Does it make sense? Does it make sense? Okay, so if that makes sense, that's great. So that's just like a very high level idea. This two freed chunk, like it is one chunk, right? But then when you do the 2 times the free, it actually doesn't have to be like next to that. Like you free this chunk again, and then right after that, you free it again. You can't wait for a long while. I mean, the Tcash chain, it can be, the chunk and then some other stuff, and then have the same chunk again. But in any case, as long as you have 2 identical chunks that occur on the chain for twice, you will have a chance to get this chunk out by reallocating it, and still have this freed chunk in the chain. Okay? Yeah, okay, if that makes sense on the high level, then that's great. We can walk through this process and understand how this can work. Okay? Good. So let's say that we have a chunk, it's called chunk 1, and then we got it free for twice. Yes.
Like before we get it twice,
Mhm.
so that's why we have a chance of getting it. In the Tcash, before it is appearing twice, so that's why we have a chance of getting it like once. Or
So for Tcash, when you free it, it will be on Tcash. If you free it for twice, it will occur on the Tcash for twice.
yes, yeah.
Yes, exactly.
So if for once it is protected, second time we are able to find it. It is like the logic is like that.
Right. The logic is like that. So like the way that a Tcash works is that it doesn't, I mean, at least for this version of Tcash, it doesn't really check if this chunk is already in the Tcash, like after it's freed. What it does, it's just like, okay, I see a chunk is being freed, I just link that chunk to the Tcash chain without checking if this chunk is already in the chain. Okay? Yeah, question.
So, for use after free, we create a pointer and then make that to again by, modifying the metadata of the free chunk, right? But
Mhm.
for free twice, you're, modifying the chunk itself instead of creating a new point. Is that what you're saying?
We're not really modifying the chunk. So the chunk doesn't, I mean, yeah, I'm just like, we don't change any information from the chunk at this point. I mean, the vulnerability itself, it doesn't change anything about the chunk. What it does is just, it wants to build a data structure where there are 2 identical chunks in this chain.
So why are we doing that? Why don't we just use after free?
Oh, of course, I mean, if there is use after free vulnerability, then we can use that. Right now, we're just talking about another type of vulnerability. It's like, you're asking, why don't we use buffer flow instead of format string, right? Of course, if there's format string, no great, the same, yeah. Okay, so then coming back to this mechanism, how it works. So say that we have 2 chunks, right? And then we have 1 chunk, and then we free the chunk for twice. So that's why if you look at the Tcache chain, these two chunks are gonna link together, although they're actually one chunk, right? So basically you have chunk one points to chunk one. Exactly? Yeah, but not exactly. I mean, like, yes, right? Okay, good. And then the next is that when we do malloc, then according to Tcache will just go through the chain and find the first chunk and then use that, like extract, pull that out from the chain and then return that back to the user, right? So in that case, then chunk one will be in use, means that the chunk one will be returned back to the user, right? Okay, and now at this point, this is identical to use after free, basically, right? Because this is identical in the sense that chunk one is freed because it's in the Tcache. But it's also going to be used because now the user is having chunk one after this malloc. Does it make sense?
So at the same
Yeah.
time, the pointer of chunk one is in the use memory as well as in the free memory.
Exactly. Yes, that's a very good synthesis. So as long as this chunk is both in the freed chunk, like freed memory, means that it's in the Tcache, and also it's in the used memory, you can trigger this type of vulnerability or this category of vulnerability. It just like use after free or double free. It's just like two ways that you can make this condition happen. Does it make sense? Good. Okay, cool. If this makes sense to you, then that's great. It means that now you can very flexibly kind of convert what you have done for use after free to double free. Because now that means that you have this chunk one in use after you do malloc, right? And then you just start to change the metadata field, right? You change that information to make the Tcache thought that the freed chunk one is going to point to another victim, right? And then after that, you just do a malloc chunk one again, malloc again, because now this chunk, oh, where's my mouse? Here we go. Because after step 5 malloc, this chunk one will be returned, which we don't really care because what we want to have is the victim chunk, right? So then we do a second time of malloc, which is step 6, we will get the second chunk. And then starting from there, it's going to be similar to what we did. We can do arbitrary read, write, and then start from there. We can also invoke an arbitrary execution. Make sense? Good. Yes, question.
So, after we free and, then we get the chunk to use, right? So
Right.
now chunk one is in use.
Mhm.
So why doesn't the program, let the metadata should not be used after that once it's gone back to the in-use state, right?
That's right. So, and that's the problem, or say that's the vulnerability design issue of Tcache. They should, like the Tcache, when it got malloc again, like step number 5, it should check the flag of the chunk, making sure that this chunk is for sure that not being used right now, but they don't have this check mechanism. And that's why you can edit chunk 1 at 4, because by the time that you malloc the chunk, you already turning this flag to be in use, right? Yeah. Okay, good. So, I mean, the rest is pretty much the same. Just like it's the same slides. Actually, I just copy paste the slides. So like you have the arbitrary execution starting from arbitrary read and write, and that's it for double free. And then, as I mentioned, you don't really have to make these two chunks, like chunk 1 and chunk 1, really like link them right next to each other. It's okay that you have, chunk 1 points to something else and then chunk 1. So it's like in this case. It could be that you have chunk 1, say this is hash, right? And then points to, say, chunk 2, points to chunk 3, and then chunk 1. It's okay that you have something in the middle. It doesn't really matter, right? As long as you have 2 chunks together, both like two identical chunks in the chain, you're good. Because ultimately, all you want to make sure is that after this chunk got moved out of the key hash, which is like through malloc, right? After this chunk being used, you still have this chunk in the free list. Make sense? Good. Yeah.
Will that mean you have to malloc like that many number of times?
Yes, in that case, like in order to use the, to make this, well, actually, let me say that again. No. The reason is that this is all like the way that you do the key has been free, right? But then now if you're gonna use malloc, you only need to do malloc once to have that. Or I may misinterpret your question. If you are talking about later on how to like use this, then yes, basically you need to first, I'm gonna write this, okay, so that we can understand which chunk that we're talking about. So the first time that we have malloc, it will return chunk 1-1. And then after that, you start to add it, right? Like let's have 1-1 is equal to some value. Right? And then in order to get the victim, you need to malloc 1, 2, 3, 4 times. Okay, cool. And that's it for double free. It's actually not very hard, I would say. I mean, especially if you already understand the nature of having this kind of a vulnerability, right? Which is like one is still in free, but then you can still access it. Right now, you kind of understand how this possibly works. And then that's it. And then if there is more questions about double free, let's have the lab of today. Okay, sounds good? Cool. Okay, so one second. Oh, and by the way, for heap overflow, is there any questions? No? Okay. So where is -8?
Your lab.
Sorry, in my lab?
Yeah, in the lab, you do like this.
What did I do? Could you
So
like,
it's like for the first block, we have like 32 bytes. 32 bytes for the first chunk.
Mhm.
So you're doing like 32 minus 8 to leave the first 0x21 flag. You're leaving that because you're like starting from here, right here. So that's where you're leaving this. So that's where like 8, 82, 24 for the first one, then followed by the second.
cool?
The 8 bytes, the metadata of first one.
Yes, it's the offset basically.
Okay, so, then if you're writing the second byte, won't that have metadata too?
Sorry, yeah.
2-1, so that's right. Like we're writing 24 bytes garbage, and then we're going like 21 we're writing, and we're going process. Yeah, so
Yeah.
the second one, then we're writing like the victim.
Good. Okay, so lab, same IP, port is 12222, similar as what we had last time, you know. For files, libraries, don't forget about that, and then you should be able to run it. So now it's 10:55. I will give you, say, until 11:15, and then starting from there, we're gonna work on this challenge together.
Hopefully, just going and all the same, probably.
You mean directly run double free? Like the binary? Yeah. Mhm.
When I try to pay twice, it says double fee per hour.
Because did you use the light? Well, actually, let me just complete.
mean, it should be relevant. Like, I think the problem is that you're offering the
And then I listed how many classes. Then I thought I didn't see pointer is there. Okay. And the size of this is there. Yeah, so what we do is we create. So if we create if we arrange it, now we look to the system, but it's a good real. There was chunk one and so we get against chunk one. Okay, let me I create it once. I create it again. And now when I look at it again, now what I when I listed it, one is created, one is under use for the content. Yeah, I got it. The base for you have to do two or three. How many people are there and how many times we can use different. Okay, so that in manner plus and three twice again in manner plus. Yeah, and pointer. And then I think that edit pointer now. Oh, edit pointer. To see here. You have to make 0, 1, 3, 1, 1 in the middle. What are the index? Okay. How many times you have that is the index number? That is not
All right, guys, I hope that you are ready to work on this together, or you are already exploited. I saw many of you are already, exploited by yourself. That's good job. If you can't, that's okay. We're gonna work on this together now. So yeah, let me move my screen real quick. Let's go to the program. And actually, let's GDB with the program so that we can run it, and then in the meanwhile, check the beans with it. Okay. All right. So first, let's start to run it. So I am going to first, just according to what we have had for double free, the first thing we're going to do is just like malloc something, right? And then we start to do the first time of free. Okay. And then let's take a look at the beans. So after the first time of free, this is the item. This is the, the free chunk that is in the Tcash beans, right? Okay, and then I'm gonna write this out in the whiteboard so that we can remember when we have that. So the first is we do a malloc, right? And then the second is we do a free, right? And then the next is let's do free again. Okay. All right, so let's continue. So we are going to free again. Okay, and then let's take a look at the beans. So now you have chunk, same chunk, but then it kind of connect to each other, like connect to the self, right? So chunk one talks to chunk one. Good. And then the next.
Excuse
sorry, I just see
Professor.
message saying that the people
Yeah.
from Zoom cannot see my screen. Let me reshare. Sorry about that. Okay. All right, and then just to sync up with the students from Zoom real quick. So right now we are running a program and debugging it with GDB. And what we have done is that we do one-time malloc. Actually, let me just do this right again, okay? Because it's going to be very, very fast. We do a malloc, right? And then after that, we do a free. And then we do a free again. And we stop there. We look at the beans. So right now in the Tcash beans, we have this chunk that links to itself, right? So if you see that these two addresses are yes, there are two addresses. So these two addresses are the same. Okay. Okay, so they're the same. They're same. And then the next that what we're gonna do is that we want to, do a malloc again so that we can access one of the chunk and then start to change the information, right? So the next will be, let's do malloc, same size. Well, it doesn't really have to be same size. As long as the size will goes to the same chunk size, then we're good, okay? So now let's again set a breakpoint or like interrupt and then do beans. It's still there, but let me continue. I want to, what I should do? Okay, let me list the pointers. Okay, so we do have that, right? Yeah, so we have this. And then actually what we should do here is, let's continue. Actually, let me pause here real quick to look at the heap. Okay. So now we know that we already own this chunk, right? And then the next that we should do is start to change the value of this part, right? So that it will be able to help us to change the metadata. So what we want to change is have this address to be somewhere on the GOT table entry, right? So let's find the GOT table. Somewhere that we're interested in, let's still use malloc. So let's make this address, okay? So when you interact with the, with the, with the service, you want to convert this into, the using P64 to convert that to little endian so that the program can digest that. But now what I'm going to do is I will just directly change the value here. So I am going to do set this equal to this value. Okay. All right, so after that, let's take a look at the beans, what it looks like. Okay, so now the bean said the freight chunk, after the freight, it will point to this entry, right? Okay, so now let me write the step on the board real quick. After the freight, we do a malloc again, right? And then say this returns us a P. And then we make this value equal to the GOT tables of malloc. The entry of malloc in GOT table. Okay. All right. So this is where we're at right now. So the next step that we're going to do is to malloc again, right? Okay. So let's continue. Let's malloc. And then take a look at what we have. Okay, so malloc again, yes, it's the same pointers. But if we do the second time, we should be able to get, which is the GOT tables entry, right? Good. So then the next is that we want to change the value there, right? So hopefully we want to change this value to the current address of the win function, right? Okay, so what we are going to do, we are going to set that value. I need to figure it out the win function. Where is it? Okay, let me do this real quick. So here, this is the address of win, and then we want to make this address stays in the GOT entry of malloc, right? Which is this, right? So we have this is equal to win, and then you should be able to do that using this added, the added command. And the reason why I'm not doing that right now is because in order to send that command, I have to make the string to be the converted value of the value, like of the function. But then that string is not really typable. So that's why I'm just like using this hex to achieve the same effect, which is to make this pointer's value or make this the reference and then have that value equal to the function's address. Okay, good. So after that, then we should continue. And then we just do a random malloc again. Good. Now I don't know where I'm at now. Sounds like, okay. So now it has a segmentation fault. I think this might be because of so this is because the value that I put on malloc is wrong. Okay, now I need to redo this again. Okay, now I'm starting from scratch and then doing malloc 8 and then free one time, free another time, right? So now I have already built up the chunk has the chain with two identical chunks pointing to each other, and then malloc again. So I should get the chunk now, and I'm gonna do I need to get the value. Okay, so it is this guy. I want to change this to the GOT tables value, right? Which is going to be set. This is right? Okay, and then let's check the beans. Okay, so it is correct. Okay, so the next we are going to continue. And we are going to do malloc again. And let's see how it looks like now. Okay, so we have one chunk that is left here. We'll continue. We do malloc again. So we have this chunk, right? Okay, and then the next is that we want to set not this one. Actually, let me take a look at the chunks. What is the value of it? Oh, let me take a look at the docs tables value. It is malloc. Where is malloc? It's here. Okay. So okay. And then let me see God again. Where is it? So the reason why this is wrong is because I need to set also this part. So I need to set this to be the entire, like it has to be 8 bytes. So, but now I only set 4 bytes value. Okay. All right, so let me just add this a little bit. Okay, now we're good. All right, continue. So the next is we're going to do malloc again. There we go. And now they're asking us, you know, what is the ASU write ID? And that's it. Okay, good, cool. Okay, yeah. So I think that in my implementation, when you do added, it will already read this entire value as like 8 bytes. So you don't really have to do this like 2 times of added again. Okay, like you should be able to just give it added for 1 time, and it will treat the entire value like extend it to 8 bytes and then move that to the according chunk. So yeah, so you know, connecting all this together is that after you have this, and then you want to do 2 times this malloc again, right? And then after that, this should be, I'm gonna call it P2. And then this should be the GOT. Right, so it should be actually this value, the GOT table, right? And then is that we just need to make this GOT table value to be the address of Wii function. And then we just call malloc again, which is equivalent to call Wii, and we will be able to log the participation. Okay, good. So is there any questions regarding this? No? Yes.
I think I may have missed something.
Because the code of like double3.c had the chunks of edit, screen and allocating. That's why we were able to directly use it in the options from Python. Like we're directly able to say, okay, do M0.
Exactly, exactly.
What if those chunks of code pieces are not there in the C file? Like we have to, do we have to write this edit function on our own using or like?
Yes.
That's what I'm not sure. Like if those chunks are not there in the C file, then how do we allocate memory? How do we read the memory and how do we edit those memory?
Yes, yes. So question, if those chunks are not in the C file, how are we gonna manage to allocate the memory? So like the C file that I give you is just a very simple, and also like extremely simplified case that expose all the malloc and the free to you directly, right? But then in the real world, you like in most of the times you want to be able to see that free or to that malloc, like in a very like straightforward way. Like there's not going to be a menu with the option that you need to do this, right? However, you need to analyze the program and then find those functions that has, say, free, and it has a malloc. And then you need to use your exploit to kind of control the program to execute them in the right order, so that you can trigger a buffer, like double free or use of the free vulnerability. Yeah. Okay, cool, yeah. If there's no more questions, that's it for today. Yeah, please track the Discord because I'm gonna initiate the poll real quick. And then we can make a decision for assignment 2 from there. All right, thank you.